Welcome back to Coding with Vishwa. In today's video, from our C programming tutorial playlist, we are diving into the most important topic in programming, which is operations on array. Arrays allows us to store multiple values in a single variable, and by mastering operations on array, we can efficiently handle and manipulate large set of data in our programming. We will cover the most important or essential operations like traversal, insertion, deletion, searching, updating, sorting, and also merging of arrays. Whether you are a beginner or just revising your concepts, this video will give you clear understanding with a simple example. So grab your compiler and let's start coding with arrays in C. First we will start with traversal. Traversal of an array means accessing or processing each element of an array exactly once, usually using loops. Traversal is used in mainly three cases. They are to display elements, to search for a value, or to perform operations on each element like addition, subtraction. Now let us understand these with the help of simple C program on array. Now we are using VS Code as a C compiler. We have created one file called example.c in which we have written a simple C program. This is a basic syntax of C program. Now we will declare one array int a of 5, where 5 is the size of the array. Next we will assign a value to it 10, 20, 30, 40, 50. And next we will declare one variable int I to use in loop. Next we will give for loop for I equal to 0, I less than 5, I plus plus. Next we will give one printf statement, printf percentage d, comma a of I. This for loop is used to print each element of this array from 10 to 50. Now let us save this and execute it. After executing, we got 10, 20, 30, 40, 50 as an output. We will see how to perform operation on this array. First we will comment it out. Next we will declare another variable int sum to calculate sum. First we will assign it to 0. Next we will give for loop for I equal to 0, I less than n, I equal to 0, I less than 5, I plus plus. Next we will give sum equal to sum plus a of I. After this for loop, we will give one printf statement, printf percentage d, comma sum. For more clarity, you can give sum equal to percentage d. Now let us save it and execute it. After executing, we got sum equal to 150 as an output. If you have any doubt about this for loop, we have uploaded the video in our channel, so you can watch it. Next, we have insertion. Insertion in an array means adding a new element at a specific position. Since arrays have fixed size and continuous memory allocation, to add a new element at a specific position, we need to shift the remaining elements to make space for the new element. Insertion is often used in the following cases: inserting a new value in the middle, adding a value at a beginning or end, updating data in a list. Now let us write one C program to understand these three uses. First we will declare array of size 5, and next we will assign only 4 variables 10, 20, 40, 50. And in this program we will try to add 30 at index 2. So we will declare one variable int position which is equal to 2, where we will add the element 30. So we will declare another variable int ele which is equal to 30, and next another variable int I to use in the for loop. First we will try to print the original array for I equal to 0, I less than 4, I plus plus. And next we will go printf statement, printf percentage d, comma a of I. To this we will give printf /n to get the resultant array in the next line. Next we will give another for loop for I equal to size. In our example, size equal to 4, comma I greater than position I minus minus. In this for loop, we will perform operation called a of I, which is equal to a of I minus 1. After this for loop, we will perform a of position, which is equal to ELE. Now we will try to print the array once again. So let us copy this and paste it again. And let us change the size to 5 because we have added another element. Now let us try to execute it. After executing, in the first time we got a 10, 20, 40, 50 as an output. After this making changes, we got 10, 20, 30, 40, 50 as an output. 30 got placed in the index 2 and 40 and 50 are shifted to the right. Next we have deletion. Deletion in an array means removing an element from a specific position. In this deletion, we cannot actually remove the element. Instead, we shift the remaining elements to the left side. Deletion is often used in the following cases: to remove the unwanted data, to free up the space for new insertion, to keep the array updated and organized. Now, let us try to understand this with one C program. This is a previous example where we have added 30 at the index 2. Now, let us try to delete 30 from the given array. First, we will remove this and declare one array int a of 5, which is equal to 10, 20, 30, 40, 50. And to delete 30, we need to place 40 in the place of 30 and 50 in the place of 40. So, we will declare one variable int position, which is equal to 2 because 30 is present in the position 2. Next, we will give another variable int I to use in the for loop. Now, we will run a for loop which will start from this position and go up to the size minus 1, which is 4. For I equal to position, comma I less than size minus 1, which is equal to 4, I plus plus. In this for loop, we will shift the elements to the left by giving a of I is equal to a of I plus 1. By this operation, the elements will be get shifted from this index to the index before it. After this, let us try to print it for I equal to 0, I less than 4, I plus plus. Next, we will go printf statement, printf percentage %d, comma a of I. Now, let us try to execute it. First, we will save this and execute it. After executing, we got 10, 20, 40, 50 as an output. Because 30 is replaced by 40 and 40 is replaced by 50. By this way, we can delete 30 from the given set of array. Next, we have searching. Searching means finding the position of a specific element in an array. There are two common types of searching, which are linear search and binary search. Linear search operates on unsorted array, but binary search operates on sorted array, and which is more efficient than linear search. Now let us write code for both linear search and binary search. First we will write code for linear search, in which we will declare one array int a of 5, which is equal to 10, 30, 20, 40, 50. And next we will declare int ELE, which is equal to 30, which is the element we are going to search in this given array. Now we will declare another variable int found, which is equal to 0, to indicate that element is found or not found. Next we will run for loop for I equal to 0, I less than 5, or we have forgotten the semicolon, I plus plus. Next we will check condition if a of I equal to ELE, then we will give found equal to 1 and give printf element exist. Next we will give break. After this for loop we will check another condition if not of found, then we will give printf statement, printf element not exist. Now in this for loop the element will be get checked with every element in this array. First it will be compared with 10. If it not matched, next it will be compared with 30. With this 30 and 30 will get matched and found will be changed to 1 and element exist will be get printed, and break statement will be executed, and a break statement will execute. The next iteration of this for loop will not get executed. Now let us try to execute it. After executing we got element exist as an output. Now let us try with another element, for example 35, and execute it. After executing we got element not exist as an output. Now let us comment it out. Next we will write code for binary search. In binary search also we need to declare one array int a of 5, which is equal to 10, 20, 30, 40, 50. In binary search we need to declare array which is in ascending order. Next we will declare one variable int ELE, which is equal to 30, which is the element we are trying to find. Next we will declare another variable found, which is equal to 0. Next we will declare three variables low, which is equal to 0, high, which is equal to size of that array minus 1. Our array size is 5, 5 minus 1 is 4, mid. Next we will run while loop. While low less than or equal to high, we will run this while loop. Next we will assign middle equal to low plus high divided by 2. Next we will give if condition if a of mid equal to ELE, then found equal to 1, printf element exist, and next we will give break. After this if condition we will give if else if a of mid is less than ELE, then low equal to mid plus 1, else high equal to mid minus 1. After this we will give another if condition if not of found, then printf element not exist. Now let us understand this code. First we have declared a low, which is equal to 0, means index of the first variable. Next we have declared a high, which is the index of the last variable. In this while loop we will check condition low is less than or equal to high. In the first iteration it will be true, and next we will assign mid equal to low plus high by 2, low equal to 0, high equal to 4. When we add these two, we will get 4 by 2, which is equal to 2. Now middle value equal to 30. A of mid, which is equal to 30. 30 will be get compared to 30, and this comparison becomes true, and the value of found is changed to 1, and we will get element exists as an output. First we will clear this output and save this and execute it. After executing, we got element exists as an output. Now let us try with 35. Here in this code, 35 will not match with 30, and next it will check another condition. If a of mid is less than ELE, now a of mid is 30 and ELE is 35. This condition becomes true, and low will be equal to mid plus 1, which is equal to low equal to 3. And in the next iteration, 3 is less than or equal to 4. This condition will become true, and it will enter into the loop. Next, it will check mid equal to low plus high by 2. Low is 3 and high is 4. 3 plus 4 is 7. 7 by 2, which is equal to 3. Next, if A of mid equal to ELE, A of mid, A of 3 is 40. 40 equal to ELE. 40 equal to ELE, and the condition becomes false. Next, it will check A of mid is less than ELE. A of mid equal to 40 and ELE equal to 35. This condition also becomes false. Next, it will execute this high equal to mid minus 1. Middle value is 3. 3 minus 1, which is equal to 2. Now this condition becomes false, and the control gets out of this while loop and execute this if condition, and we will get element not exist as an output. Now let us try to execute it. After executing, we got element not found as an output. Now let us learn how to update an element in an array. Updating an array means changing the value of an existing element at a particular index. Suppose we want to change the value at a specific index, we simply assign a new value to that index using assignment operator. For example, if you want to change the third element in an array from 30 to 99, we will write array of 2 equal to 99. Now let us code this and see. To perform update operation, first we need to declare one array int a of 5, which is equal to 10, 20, 30, 40, 50. And next we will give element int ELE, which is equal to 60, and int position, which is equal to 3. To update the value at the position 3, we simply assign a of position equal to ELE. And now let us try to print it. Printf %d comma a of 3. And now let us save it and execute it. After executing, we got a of 3, 60 as the output. The element 40 got replaced by 60. Next we have sorting. Sorting means arranging the elements in an array in a specific order. For example, ascending order or descending order. Common sorting algorithms in C are bubble sort, selection sort, insertion sort, quick sort. Now in this video we will see bubble sort, and if you want a video on selection sort, insertion sort and quick sort, please let us know in the comment section. Now let us write code for bubble sort, for which we declare array int a of 5, which is equal to 10, 30, 50, 40, 20. And now let us declare another variable int n, which is equal to 5, which is the size of our array, and another variable I and another variable j to use in the for loop. And now let us declare another variable temp to use in the bubble sort. Now let us write a for loop for I equal to 0, I less than n, I plus plus. And in this for loop we will write another for loop This is the nested for loop for j equal to 0, j less than n minus I minus 1, j plus plus. In this for loop, we will check one condition. If a of j is greater than a of j plus 1, then we will swap a of j and a of j plus 1. So we will give temp equal to a of j, temp equal to a of j. Next we will give a of j equal to a of j plus 1, and in the next line a of j plus 1 equal to temp. After this for loop, we will give another for loop to print the elements for I equal to 0, I less than n, I plus plus, and we will give printf statement, printf percentage d, comma a of I. Now let us understand this code. This outer for loop is used to check the one element with other remaining elements, and inner for loop is used to iterate through this array. During first iteration, the I value will be at 0 where the value is 10, and the j value will also be at 0. Here we will check the condition a of j is greater than a of j plus 1. Here 10 is not greater than 40, so these statements are not executed. In the next iteration, j will be equal to 2, and a of j 40 we will check with 50. 40 is not greater than 50, so these statements will not executed. In the next iteration, j equal to 2 and 50 will be greater than 40, so these statements will be get executed. After executing these statements, 50 will be replaced by 40 and 40 will be replaced by 50. The place of 50 and 40 will get changed. This steps continuous, and after executing these two for loop, we will get a sorted array, and we use this printf statements to print the array elements. Now let us try to save it and execute it. After executing, we got 10, 20, 40, 40, 50 as an output. This is in ascending order. If you want in descending order, we should change this condition and execute it. After executing, we got all the elements in descending order. Last we have merging. Merging array means combining two arrays into a single array. Now let us write a code for merging and understand it. For merging operation, we need to declare three arrays. Now we will declare three array int a of 5, which is equal to 1, 3, 5, 7, 9, and another array int b of 5, which is equal to 2, 4, 6, 8, 10, and at last we will declare another array which is a resultant array c of 10. And now let us write a for loop for I equal to 0, I less than 5, I plus plus. We need to declare this I int I, and in this for loop we will give assignment operation where c of I equal to a of I, and after this for loop we will give another for loop for int I equal to 5, I less than 10, I plus plus. In this for loop we will give assignment operation c of I equal to b of I minus 5, c of I equal to b of I minus 5. After this we will give another for loop to print the resultant array for I equal to 0, I less than 10, I plus plus. In this we will give printf statement printf percentage d, comma a c of I. First in this for loop, c of 0 will be placed by the a of 0, which is 1, After completion of this for loop, C of 0 to C of 4 will be get filled. In this for loop, C of 5 will get filled with B of 5 minus 5, which is 0, which is the 2. 2 is placed in the position of C of 5, and after executing this for loop, the array elements will be placed in the C array. After executing this, we will get a resultant array, which is the combination of A and B. Here we have not declared the I. Now let us save it and execute it. After executing, we got 1, 3, 5, 7, 9, 2, 4, 6, 8, 10 as an output, which is the combination of A and B array. So that completes the key operation on array. These operations form a foundation of working with the data in C and are super important for every beginners to master. If you understand everything, give thumbs up in the comment section. If not, feel free to rewatch this video or drop down the doubts in the comment. I am here to help. If you found this video helpful, don't forget to like, share and subscribe to our channel for more clear and beginner friendly C programming tutorial. See you in the next video. Until then, keep learning and keep coding.